From Kansas State University, this is Agriculture Today. I'm Shelby Varner. K-State Precision Agriculture economist Terry Griffin and principal scientist at the Aerospace Corporation, Dr. Rebecca Bishop, start today's show discussing how space weather could impact agriculture. Terry and Rebecca keep the show going by continuing their conversation about space and resources where people can keep up to date about what is happening. We round out today's show with a reminder it's almost time to plant garlic. K-State horticulturist Ward Upham explains the process for planting garlic this fall so it's ready for harvesting in early to mid-June. That and more is coming up ahead on Agriculture Today. You're tuned in to Agriculture Today, and we start our show discussing how space weather affects agriculture. And in to talk on this topic, we have K-State Precision Agriculture economist Terry Griffin, and he's joined by principal scientist at the Aerospace Corporation, Dr. Rebecca Bishop. Terry, Rebecca, thanks for joining us today.
Nice to be here.
Thank you, Shelby. It's great to be here.
Rebecca, what is solar activity and space weather?
So space weather and solar activity, they're a little bit linked. So space weather is weather that occurs at the higher altitudes, just like we have everyday weather close to the surface, and that's in the lower altitudes of the atmosphere. But the Earth's atmosphere actually extends thousands and thousands of kilometers out, very low density atmosphere, but there still is weather. There's still winds, there's still waves, and there's plasma or charged particles. And so the sun actually is also shooting out radiation and charged particles all the time. And as it hits the Earth's magnetic field, it can actually produce a lot of different effects that produce space weather. The more disturbed the sun becomes, the more likely some of those effects will reach us and our technology systems. CMEs, or coronal mass ejections, are one type of solar activity. And those are really strong eruptions from the sun. And they basically shoot out a lot of charged particles, plasma, we call it. And that can take anywhere from 12 hours to a couple of days to reach Earth. And how it affects Earth depends on what time of day it hits, as well as what the orientation of our magnetic field, the Earth's magnetic field, is to produce some of these various different effects. But the sun is not the only thing that produces space weather. We actually see a chain between lower surface weather and effects in what we call the ionosphere, or the region of charged plasma around the Earth, driven by like the jet stream or big weather systems, tropical storms, that sort of thing that produce waves that will actually start space weather at higher altitudes.
How often is Earth being affected by space weather?
That's a good question. It all depends on how you define space weather, because you think about in your day-to-day forecast, weather is happening all the time down here on the surface. It's just whether it's severe, moderate, or quiet weather. And you can think about it the same way up in space or in the near space, Earth space environment. It's happening all the time. The extreme events happen less regularly. Moderate events can happen on a good cadence. All of that is also tied into the 11-year solar cycle. So when solar activity increases, you're more likely to get some extreme events that will have larger effects. Space weather can happen both locally and globally.
For space weather, is the whole Earth impacted, or are usually just parts of the Earth impacted?
The Earth didn't make it easy for us to answer those sorts of questions, because a lot of it is driven by the orientation of the Earth's magnetic field, which isn't uniform all the way across. So the effects aren't always uniform globally from space weather. It really depends on what the magnetic field is doing at your locale. And that's why South America often sees a lot more severe space weather than the continental U.S. because they have a different magnetic field, without getting into all the gritty details. The severe storms will have an impact globally. And then also your storms, you're likely are going to see that impact, the solar storms, impact at higher latitudes first. The stronger the storms, the lower in latitude the effects become. The other type of space weather, actually, that may be driven by lower atmospheric coupling or just internal coupling can happen at low latitudes and more closer to the equator, but it tends to be a different type of space weather. And that tends not to go up to higher latitudes. So it's really kind of a big soupy mess of weather up there.
So, Rebecca, is it fair to say that we have weather every day kind of down here on Earth, but there's every day something's happening above us as well?
Absolutely. Just whether or not it impacts our applications, our equipment, or our technology, we don't know or we don't see.
And talking about that equipment and technology, kind of what impact can it have on the global navigation satellite system?
So basically, the way the global navigation system works is you have the GPS satellites that are transmitting a radio frequency down, and it's in a certain frequency range called L-band. As it comes down, as it passes through the region I mentioned, the ionosphere, which is a layer of charged particles, plasma, that can affect radio frequency. It can scatter it, it can bend it, it can reflect it. If the ionosphere is nice and smooth and uniform, no big deal. The signals come right through, not a problem. The moment there's any sort of turbulence or waves or any small scale structure, now all of a sudden that scattering, that reflection could happen, and the signals don't get through the ionosphere and never reach your GPS receivers on the ground. Or they're corrupted by the time they reach the ground. And so that's where the space weather, if the space weather can disturb the ionosphere enough or create really big and small scale structures, make it really like a frothy, turbulent river, think of it, then the signals aren't going to get through.
Terry, from an agricultural perspective, then, how do you see that impacting efficiency for our farmers?
Even if we look at social media from farmers tweeting issues that they're having with GPS, recently I saw one that was mentioning that WAS was not working for them. And it happened during a spike in the KP, planetary K index. And I don't know if it was connected, but it was, let's say, correlated to that event. And, you know, as a user of technology, if something's not working, you know, my first reaction is to unplug, plug it back in, restart it, call the dealer. But if it is from ionospheric scintillation, those things aren't going to help, you know, and what may help is just waiting it out. You know, Rebecca, if we did have a local outage, is it, you know, days or minutes or hours that we're going to have a lack of GPS connectivity, or what's the time frame?
So typically it's going to be hours. It could be minutes to hours, not days, unless we have once in a lifetime event. Sort of thing. But I'd also like to go back just a little bit, and we're talking about scintillation, which is, you know, the scattering or reflecting or preventing of signals coming through. You can think of scintillation almost as jamming, and it's natural jamming versus man-made jamming. And this scintillation or the natural jamming happens at night. It typically doesn't happen during the day.
Oh, really? Okay.
Yeah, it's very hard to get it during the day, because the ionosphere is produced by the sun. So it is constantly, it's really hard to disturb the whole ocean, right? And make the whole ocean turbulent all at once. During the day, the ionosphere is like the ocean. At night, the ionosphere is like a pond. And it's really easy to go in and whip up a pond and make it really turbulent. And so that's how you can think of scintillation. You might get a little bit during the day. There's questions on that, but probably not most of it. And primarily it's always at night.
On the agricultural side, you know, with GPS now, I guess the last 20 something years, we've been using GPS for a lot of our field activities. And one of the benefits of that is we are less reliant upon daylight to do field operations. So a lot of tillage, for instance, planting would happen during the nighttime. And some operations may do a 24-hour with different shifts of labor because GPS has provided that opportunity. So there would potentially be some nighttime.
So there is something called solar radio bursts, and they can interfere. And that's a very specific type of solar activity. a solar radiation burst, so CME is one type, a solar radiation burst is another type. That can create blackouts. That, depending on what goes on, could occur at any time during the day, I believe.
Rebecca, when we're talking about this, and you talked about the pond versus the ocean, so kind of moving it to, per se, a land, more than likely, like maybe a few counties are going to be impacted versus the whole state, or is it more than likely one state versus the whole country?
So for the low latitude scintillation, and we'll talk at the nighttime scintillation, that tends to be like state size, and it happens to be more longitudinally aligned. So they're like chords a little bit. Solar radio bursts, big geomagnetic storms, they can be continental wide, they can be hemispheric wide, it tend to be, high latitude auroral. So it can be all unfortunately, answering your question is it could be all of the above. It really depends on what is the source of the space weather. And we've talked scintillation, we've talked CMEs, but there's a bunch of other things. There's the geomagnetic storms, which have a relationship to those things. There are solar flares, and there's solar radio emissions. So I go back to my earlier comment, is that it's a giant soup of things going on.
That was Principal Scientist at the Aerospace Corporation, Dr. Rebecca Bishop, and she was joined by Kansas State University Precision Agriculture economist Terry Griffin as they discussed what is space weather and how it affects agriculture. We're cutting to a short break now on Agriculture Today, but when we come back, we'll once again be joined by Terry and Rebecca as they continue their conversation and share resources for people if they'd like to keep up to date. You're tuned back into Agriculture Today, and we continue our conversation with Principal Scientist at the Aerospace Corporation, Dr. Rebecca Bishop, and K-State Precision Agriculture economist Terry Griffin. And Rebecca, how is space impacting the Earth, or what are those different factors?
It's a combination of factors. One is the growth in GNSS or GPS technology over the last 2-3 decades. It's now such an integrated part in almost every aspect of our daily lives. Systems, any electronic system probably has something related to GPS in it. So it's just everywhere. As far as solar activity, the last couple of solar cycles have been fairly quiet. We've gotten some really big storms. You may have heard of a Halloween storm a few years back, which was huge, and it happened during a solar minimum, or at least solar quiet. We're moving right now into solar max. We didn't think it would be that strong of a solar max, but it is surprising us, and it's picking up. So for the last 2 decades, the solar cycles have been pretty quiet, and that's the decades that we have grown in our dependency of GNSS. Solar cycle picks up, more type of events happen, we may start seeing more of an impact. Because up until this point, a lot of the engineers and designs didn't really take that into consideration because, they had technical mitigations or technical workarounds. Now, those workarounds may not be acceptable.
And Terry, talking with Kansas ag producers and talking about possibly having GPS or things important for creating straight lines in fields for farmers, you told me you've had questions about should farmers be putting their markers back on their equipment?
So looking at the most recent statistics, earlier this year, USDA and I collaborated on an adoption study of precision agriculture. And one of the technologies, one of the most commonly adopted technologies, automated guidance. And these have been really beneficial to the planting operation. So, 20 years ago, most planters would have physical row markers, and so that we could make parallel passes to the first pass. And once GPS was added to the tractors for automated guidance, it was one of the logical next steps was to not get physical row markers. And one of the next steps after that was, since we don't have to have physical row markers, instead of having an 8-row planter, let's have a 16-row or a 32-row planter or larger. And row markers for those larger sizes are just not common. It may become somewhat infeasible at some size. And because of the reliance upon GPS and GNSS on planter equipment. And so let's fast forward to the springtime, maybe during a Solar Max or some in events that Rebecca's talking about. If I'm using the technology to plant, and we can do it 24 hours a day, we're less reliant upon sunlight to do field operations. And my GPS isn't working. So I have two choices. Either try to put seeds in the ground that may not be in straight or contour lines relative to the original pass, or wait it out. It's as a individual, if my GNSS system's not working, I may err on the side of unplugging things, plugging them back in, restarting, in hopes of it getting a signal, or calling my local dealer. But if it is something that's beyond the equipment, it'd be, I think, beneficial for our listeners to understand what the source may be. And that in that event, assuming it would last several minutes, maybe a few hours, then waiting it out may be the optimal decision. Not to suggest everybody run out and buy 8-row planters with physical row markers to keep handy. That may be a little bit extreme for the likelihood of the event happening and the duration of those events.
As we talk about these events and the impacts that they have on agriculture, they don't really have an impact on humans, though.
That is the beauty of the Earth's magnetic field. It acts as a shield for us and actually prevents a lot of the harmful radiation that comes from the sun reaching down. And so it would take a really, really strong event to have anything that comes really low. Now, that doesn't mean it's still, some charged particles don't reach inside the Earth's atmosphere. What happens is the charged particles get captured on the magnetic field lines, and they actually flow down, and the magnetic field lines go into the poles. And as they come down the magnetic field lines, they collide with the neutral atmosphere, and that's what gives off light and actually heat as well and causes the aurora. So in a matter of, you can think it does affect us, but not health-wise. There is, you go up higher, you get exposed to more radiation just because, the atmosphere is less dense. So if you were flying airplanes, in an airplane, you might get a little bit more exposure, but not to the point that anyone has to worry. But that's a whole nother area. There are experts. There's the NOAA Space Weather Forecast Center that actually deals with putting out alerts, the FAA and so forth.
You mentioned the NOAA report. So one of the things I do almost every evening now is look at the planetary K-index to see if it's spiking. And for me personally, if it was recently almost 7, and
that's huge.
And for our farmers and producers listening, is there a metric or a website that they can look at to see if they may be impacted by one of these phenomena?
There is, and it is NOAA Space Weather Prediction Center. They have a website. You can also sign up for alerts through social media that they'll say, hey, a solar storm is approaching, or we expect higher activity. They have things on there like the planetary index called KP. There's another one called AP. And then there's also one that is DST, which is disturbed storm, which is actually relies on surface measurements. So it's a little bit more timely, or it's another confirmation that something really is going on. KP gives you an indication something may be going on. DST gives it, yes, something is going on, sort of thing. And just for the listeners, if you were to go to what we call SWPC, Space Weather Prediction Center, KP, they have the scales on there, and they do a green, yellow, red. And the other thing you can look at is they do have maps of like the boundary of what we call the auroral oval. And when that dips down during storm events, you're more likely to see more activity at lower altitude or lower latitudes.
Terry from Kansas State University and Rebecca from the Aerospace Corporation. What has the interaction been like between your two organizations?
So I met Rebecca, it seemed like it was at the beginning of the pandemic, and she and Aerospace Corporation were doing a SEESAW on precision agriculture. And we did a webinar, which was really good. And we had a paper that came out of that. And that's on AgManager.info for those who want to read all about these things. Rebecca, what does SEESAW, the acronym?
It's a Space Environment Engineering Science Applications Workshop. And there's been 3 SEESAW meetings. And back in 2018-19, the Aerospace Corporation had an internal initiative to better understand the end users' needs or impact of space weather on end users in technology. That's usually one of our big critical missing pieces in space weathers. We don't know who the end users are or how they're using our information or how susceptible the technology is. If we knew that, we could better drive our research in this area and improve our forecasts that could actually make a difference. And so the goal of SEESAW was to bring together the space weather forecasters, the engineers creating the systems, the end users, and people like Terry who could tell us what the economic impact of any effects would be. And it was to get everyone to have a common language, because part of it is we all use different jargon in our fields, and to understand what each group is looking for and to build those bridges and those communications so that we can actually improve how we serve the end user community, specifically in precision ag.
Terry, Rebecca, I appreciate you both taking the time to join us today and discussing how space weather may affect agriculture.
Well, thank you for having me. This has been great.
Thank you, Shelby. And Rebecca, it was great to sit down and chat about these things with you. And I really enjoyed our collaboration, and I've learned so much from working on this project.
Well, and I hope our communication will continue in the future and we can continue working together.
That was Dr. Rebecca Bishop, Principal Scientist at the Aerospace Corporation, and she was joined by Kansas State University Precision Agriculture Economist Terry Griffin. I will link the resources that they mentioned in today's interview on agtoday.net in today's show notes. Also on agtoday.net, you can find previous recordings of our show and this show, so if you're reaching your destination or missed out on some information, you can find it there on agtoday.net. We're now cutting to a short break on Agriculture Today, but we'll be back with more ahead.
This is Agriculture Today. Along with Shelby Varner, I'm Jeff Wickman. Planting garlic this fall won't offer protection against vampires this Halloween. However, you will have garlic for cooking next year in the late spring and early summer. K-State horticulturist Ward Upham discusses how to plant garlic this fall. Ward, you were mentioning to me that wheat and garlic are on a similar schedule. You plant early and harvest later.
Right. So normally you plant in early October for your garlic, but you can plant any time from late September to early November, and you'll be successful. But if you have the choice, early October is a really good time to plant the garlic. However, you don't expect a crop until the next year. About the same time as you harvest wheat, so early, mid-June, so maybe a little bit earlier than wheat, but not by much.
What about the planting process then? What do we go through for this?
So first thing is to fertilize. How much you fertilize is best if you have a soil test done and then fertilize according to the soil test. But if not, if you put 1 to 3 pounds of a 10-10-10 fertilizer per 100 square feet, you're going to be fine. Just make sure you till it in so that's not just sitting on top of the soil. And that'll also prepare the soil for your planting.
And these are bulbs, right?
They are, but they'll break apart into cloves, and you're going to plant the individual cloves. And so you're going to plant those maybe about 3 inches apart and 1 to 2 inches deep. Normally, they'll tell you that you want the pointed end up. I don't know if it makes that much difference. You don't want it down, but if it's on the side, it's going to be fine. So don't worry too much about that. They should be fine as long as you plant them from the soil and water them in well. That may be really important this year because you don't want dry soil around them because they need to start growing in the fall. You're going to see some growth in the fall. It's not going to be a whole lot, but it'll be some. And when it gets in the coolest part of the winter, that growth is going to die to the ground. And that's fine. You expect that. And then in the spring, you're going to get a lot of very vigorous growth. The other thing, too, you may want to consider doing is marking that bed in the fall. Because when it dies down in the winter, if you don't remember where they are, you may till them up. You till up early enough before that new growth starts in the spring, and you could destroy your crop before it even gets going.
You'll quickly find them by the smell, though, right?
Yeah, you're going to find it by these little white things that are on top of the soil.
Are there a couple of different types of garlic?
There are. There's a soft neck type and a hard neck type. Soft neck type doesn't have a hard central core in the center of those cloves, and the hard neck type does. The hardneck type tend to be more cold hardy, and there tends to be a little bit more variation in flavor and size. And so you may want to try several different types. Now, we can grow both, but what you don't want to do is take garlic out of the grocery store and try growing that. It's usually a variety known as early California, and that just isn't reliably hardy in our part of the country. So if you're going to buy garlic, it's best if you go to a garden center, because they're going to know what does well in this area. And you may want to try different types just to see what you prefer.
I guess I'm wondering, how much do you grow? I'm thinking garlic is not something you use a lot of.
It depends on the person. And so some people grow more than others. Some people only grow a clove worth. And so I would start out small, see how it does for you and how much you're going to use, and then go from there. So you may want to start out with just one bulb and break it into cloves and start there.
We mentioned that 1 to 2 inch depth for planting. That's enough to prevent it from heaving out?
Yes, it will be, because it'll grow enough in the fall to put down a root system so it doesn't heave. That's why if you plant too late, it may heave out of the ground because there's not enough of a root system to hold it in place.
Are there any signs that it is ready for harvest?
Yeah, so what you look for is about half the leaves turning a yellow color. And then go ahead and that'd be a good time to start digging it. And so easy to grow for us and easy to harvest. It's a good plant for us.
And you harvest all at once, or do you stagger this?
Normally you harvest all at once unless you have different varieties that start to mature at different times. And so if you have a different variety that doesn't turn half the leaves quite as quickly, then you're going to wait until it does.
I guess I picture this hanging up in the garage or somewhere. Is that what we do with it? How do we treat it after it's been harvested?
Yeah, there's different ways, but that's one of the possible ways you can put it in storage, is just to hang it up.
Kind of a fun thing to try if you've not tried it before, it sounds like.
It is, and a lot of people really like that fresh garlic. And so if you haven't done it and you like store-bought garlic, try it where you can get it fresh.
That's K-State horticulturist Ward Upham with information on planting and harvesting garlic. For more information, contact your local county or district extension office. And that'll do it for this edition of Agriculture Today. For Shelby Varner, I'm Jeff Wickman. This is the K-State Radio Network.